applications. The first is extensibility. ASP.NET has long implemented a provider model, which lets you create your own implementations of various services used in web applications. For example, if you don't like the membership provider built into ASP.NET, you can write your own using the same interfaces and base classes on which the standard membership services are built. So MVC is built using a much more powerful pluggable architecture that lets you substitute different providers and components if those suit your application requirements better. One example is the default view engine in MVC. The view engine is the component that dynamically builds the HTML on the server before sending it down to the client browser. And that uses the ASP.NET view engine. This is the same view engine that supports web forms and MVC applications. If that view engine doesn't work for you, such as if you want to use a different notation to build your views, then you can substitute your own view engine. And there are several popular view engines out there, such as the Spark view engine. You could also use your own routing system and controller factory. So you can plug in your own components if you don't like the default ones. So you really have three different options for each of these pluggable components. You can use the default component, and this is really the easiest option, and the one that we're going to use throughout this course. But if the default component doesn't do quite what you need, because these are built on .NET Framework classes, you can extend the default component, just like you may extend any other object within the .NET Framework. And finally, you can completely replace the default component with a new implementation of the interface or the base class. Another area to explore is blending of concerns. ASP.NET Web Forms almost forces you to combine the view and controller into a single object, which is often referred to as the page controller. And that's a term that goes back to some of the earliest days of ASP.NET. This violates the separation of concerns principle, which leads to tightly coupled modules that are hard to write and nearly impossible to test. Part of the problem is that ASP.NET's code behind file gives developers a false sense of separation of concerns. When you create a web form, you have the HTML code in a separate file from the code behind. And that's some sort of server-side Visual Basic or C# code file. But in reality, there's a tight coupling between the two, mostly because the server-side code you need to write to work with the page's server controls. And it's all too easy to write data access code in the code behind file, which couples the view with the data model. This almost certainly guarantees that you'll end up with duplicate code in multiple pages. If you're like me, you've probably written a lot of ADO.NET code directly within a code behind file. And you have to do that for this form and that form and the other form and so forth throughout your entire application, even though you're going against, say, the same table or view or stored procedure within a SQL Server database. Not good. The separation of concerns that's inherent in the MVC pattern and architecture encourages you to write better applications. The cycle of user interaction, where the user interacts with a view that causes an action method of a controller to interact with the model, ultimately resulting in presentation of another view, is ideally suited to web applications delivered using HTTP requests and responses. It really works quite well for this kind of development. Probably the biggest difference that you'll have to deal with if you're coming from web forms to MVC is the fact that MVC serves methods and not files. For most of the history of the web, server applications have responded to requests for files, and this is one example of a typical ASP.NET URL. You have the HTTP protocol, www.example.com, the domain, whatever the domain is, and then some specific file that you maybe pass in some query string parameters like ID equals 5. But it's file-based. It's requesting the index.aspx file. And ASP.NET will process that file, dynamically generate HTML that it then sends down to the client browser. But it goes out and finds that physical object. And then it, of course, runs through the page cycle and then sends that HTML. Even if you type into a browser www.example.com and don't request a specific file, there's usually a default document that is defined on the web server, and the user gets index.aspx anyway. So that's just a simplification, but you're still requesting a specific resource on the server. Now, in contrast, this is a typical MVC method request. In this case, the URL doesn't map to a physical file on the server. Ultimately, it's using physical files in order to generate the response, but this URL, it doesn't directly map to any of those files. And in this case, what it's doing, it's going to the example.com domain, it's mapping to the details action method, which is part of the home controller, and then it's passing in an ID of 5, whatever that ID value means. In most cases, it's probably the primary key or some sort of identifier for a record that you want from the server. But it can be pretty much anything you want. Now, this particular URL assumes the default settings for the routing rules defined by the MVC application using the ASP.NET routing features. You're not limited to that default settings of this controller method ID format. You can change that to suit the needs of your application. And you're also not limited to mapping URLs to action methods. You can link directly to physical files as well if that makes sense for your application. This is nice because you can mix these method-based URLs with requests for specific file-based resources. And that's a very simple example of how MVC is not limiting. It gives you those kinds of options. One of the best things you can do to make your applications more robust in the face of ongoing change is to build unit tests for them. A unit test lets you automate verification of whether a method works as you intend it to work. It also ensures that changes to your application don't break existing methods, because you can run the entire suite of unit tests every time you build or check an application into source control. The main benefit of unit testing is that it provides resilience in the face of change and forces you to write loosely coupled code so it's testable. In fact, a lot of the features in MVC were designed to make them testable. They don't necessarily make sense in the context of building applications, except that it makes the different components far more testable or far more easily testable. You can also use a test-driven development methodology, which takes testability to its extreme. This involves first writing a unit test that fails, then writing code for the application method that passes the unit test, and then you refactor the code as necessary. This kind of methodology forces you to focus on the code that actually needs to be written and how your code will actually be used by developers. And because you're writing unit tests before writing application code, you have to make testing an integral part of application development rather than afterwards as an afterthought. It's almost impossible to use automated testing with web forms applications. Now, in fairness, ASP.NET was released well before testability became such an important part of web application development. But in contrast, MVC was written from the ground up to support testing. One of the main themes of MVC, and a recurring theme throughout this course, is going to be the controller over HTML. Web form server controls provide rich functionality. That was part of the reason why ASP.NET originally took off and became so popular. You can bind them to data sources, configure them in almost infinite ways, and can provide rich web application interfaces. But the price they extract can be excessive. And I talked about view state and the problems with view state. But worst of all, they generate huge, unreadable, monolithic blocks of HTML that can be very difficult to format with cascading style sheets. You just have very little control over the generated HTML. MVC, on the other hand, gives you almost total control over the HTML sent to the browser. And the way it does this is by providing a variety of HTML helpers that automate HTML generation. Now this may sound an awful lot like a server control, but they tend to be for single elements alone. And they generate clean HTML that is very easy to access using cascading style sheets. You're free to build and use your own complicated page components and HTML helpers. MVC doesn't stop you from doing that. And it's easy to use client-side frameworks like Ajax and jQuery, and jQuery's myriad plugins to enhance how the users experience your page. You have a lot of options, a lot of flexibility that goes far beyond what you can do even in web forms in ASP.NET 4.0. And for a lot of people, one of the biggest benefits to MVC is that it's open source. This is one area where over the last few years, Microsoft has made available some of the source code for parts of the .NET framework, including some of the ASP.NET namespaces. It's also enabled debugging features in Visual Studio so you can step into framework code as necessary to solve problems with applications. But for the most part, the .NET framework is still a closed black box. You can look, but you can't touch. With MVC, Microsoft has gone a big step further. The MVC codebase is available as an open source software from their Codeplex.com open source project hosting site. This means that you can download the code to examine and play with it, as well as extend and recompile it for your own use. Best of all, they released it under the Microsoft Public License, which is a pretty liberal open source license approved by the Open Source Initiative. And it really provides very few limitations on how you can use that code. As you're learning MVC, I urge you to download the code and explore it. When you don't understand how a particular feature is working, that's a great way to learn and see what's going on behind the scenes.